Hello and welcome back to the channel. In this tutorial, I'll show you how to generate publication quality electrostatic surface potential maps using the APBS plugin in PyMOL. As we already know in the previous video, how to get PDB structures of our enzymes of interest and then how to clean. We will not be going through all of that today. I'll go straight to bringing in an already cleaned protein and then developing the electrostatic surface. So to continue, I'll type change directory, cd, and then paste the address, and then we're good to go. So ordinarily, like I said, if you have the enzyme just coming from PDB or any other database, you have to go through the cleaning steps, but we will not be doing that in this very tutorial. You can see our previous videos on how to clean your protein. So I will load the protein into the working space before I start using the plugin. We need to first generate the PDB 2QR file. It is that file that we will now bring into the PyMOL interface to generate the electrostatic surface. You can see the website here. So if you say get started, PDB ID or upload a PDB. So if you have the ID, you click. If you want to upload, you click. So select the file. Then from here, you can browse to your working directory. All right, you can see now I have uploaded or selected the protein 6SYU, that's chain A PDB, and pH, or rather take 7.4, and then it's either you work with amber or pass, but I always work with amber. And then please choose a naming output to use. Since we have taken amber here, we'll do same. Then you can ensure the new atoms are not rebuilt too close to existing atoms. Create an APBS input file. This is our major interest, but just make sure that you remove the waters from the output file. So once you have just set these basic parameters, you start job and watch it to submit. Then we have the job running. You can register to preserve your work, or you just get your results now and then you continue. Okay, you can see that our interest, the PDB2PQR, the work is completed, and you can look through, you will see it here, .pqr file. So you download, and then we can now go straight to, okay, that's now downloaded. Normally it will give it a kind of code, just note it in case you're working with several compounds. Now we have 1J, 1LO, like that. Just note it and then ensure that you're using the right one for your work. So what I normally do to ensure that by the time I try to initiate the plugin, it does not give me any error image, I already upload the, like you can see here, I've uploaded the file, the PQRO file, into my working space. Then you come to plugin, APBS electrostatics, and you can see now it's no longer red, but it's showing here no necessary selection has charges and radii. All right, so prepare molecule, we already skipped prepare molecule because we now have it in a PQRO format. Calculate maps with APBS. Once you have the interface here, the first and foremost options, grid spacing, leave that default. Then molecular surface visualization, you look at it. Then you have, okay, yes, the range of results. You can just set it to 5, 10, plus or minus, so that you have a color range from positive to neutral and to negative. So we'll leave our own at 5.0, and then of course solvent excluded surface, so that if you select the polar surface, solvent accessible surface, it's I prefer working with this anyway. And other visualizations. Okay, so once you have done that, you can just check out all the other contents, giving you a guide on what you're supposed to do. But here, confirm this is solvent dielectric 78.0, and then your temperature 310 Kelvin. Then ionic charge, ionic radius. Okay, leave all as default, but ensure that your temperature is 310 and the dielectric is 78.0. Then or zero point 0.5 or thereabout if you wish, but to change it is not difficult. Just select and change. So the same thing happens here. Anything you want to change here, but ensure any change you are initiating, you have a scientific basis for it. Then configuration, we don't have to do anything here. So since we are done setting up, you just click run and then wait for it to complete. So you can see it's running, and then all the parameters you have set in are playing out, and you wait for it to complete the process. Okay, still running, preparing run to run to PB calculations, setting up problem and all of that. Calculation first multi-grid, now number 2 multi-grid. Okay, it concludes by writing up all the map files, and then you have the work completed. So once it is now finally done, you're going to have this box indicating that the work finished successfully. So you can close, and then now you have the protein showing the electrostatic surface. So you can see here now, the positive end is blue, and then the negative end red. The midpoint neutral is white. So this gives you a kind of insight into the kind of charges and or on what part of the surface of the protein you have the type of charge. Now, in a case where you have to maybe present electrostatic differences for different, what do you call it now, different proteins, you have to ensure that the same parameters, the same scale you set for this first one is what you use across. Otherwise, visual comparisons may be misleading. So once you have done this, you can now resize and then save high publication quality image. And we also have a video in the playlist that can show you how to do that. But before we go here, I will show you now how to introduce transparency so that you can see the protein as a ribbon in your work. So here I have, I'll set transparency just in the command line, right? Set transparency to whatever you want between 0 and 1. And then you can see now that I can see the protein ring that has the ribbon inside. But it depends on how you want to present your work. And you can even go further to highlight specific amino acids, show distances between them and all of that. But these are things that are dependent on your work. and this will be demonstrated in another tutorial video. Thank you for your time. Bye.